Sixth grade lesson 13.5 is choosing the appropriate measure of center and variability. So let me refresh your memory on what measures of centers are. You've learned it, but I'll dust off those cobwebs. And center variability, and then we'll dig in. Okay, measures of center were the mean of a data set. That was the average, right? Where we added all the data pieces together and divided by how many data pieces are there. The median is that middle number. So if we took all the data set and ordered it from least to greatest, what number falls right in the middle of all of that? That's the median. And the mode is the one that is repeated the most, the number, the piece of data, the value that is repeated the most. All of those are ways to measure the center, but in some circumstances it's better to use one rather than the others, and in other circumstances one of the others might be a better choice because of situations or because of the way the data is. And so this lesson is going to help us be able to kind of piece together what to watch out for to know which is a better measure of the center than the other in different circumstances. Measure of variability would be the range. Remember, that's by taking the highest number in the values, the highest value in the data set, and subtracting from it the lowest value in the data set to see how spread out the data is. And the interquartile range, the Iqr Interquartile Range. Remember, we found that by the box plot, we would get the median of the whole data set. The upper quartile, the median of the upper part of the upper half. The lower quartile, the median of the lower half. And we would draw a box there. So if you take that upper quartile, which was the median of the upper half, and subtract from it the lower quartile, that would give you the interquartile range. And we'll look at when it's better to use this one or that one. We'll see an example of that too. All right, this one's going to go ahead and focus in on that measure of center, which in this scenario would be better to use. Thomas is writing an article for the school newsletter about a paper airplane competition. In the distance category, Kara's airplane flew 17 feet, 16 feet, 18 feet, 15 feet, and 2 feet. That one crashed right in front of her. Should Thomas use the mean, median, or mode to best describe Kara's result? Explain your reasoning. Well, they're going to walk us through finding the mean, finding the median, and we'll look at the mode as well. And then we'll decide which was a better or more accurate depiction of her numbers, her data. They asked us, do you need to order the numbers from least to greatest? We will need to, because remember, for median, we need to do that. So we can say, yeah, I will need to do that. I will for median. For mean, though, I don't need to, so I'm just going to list these numbers: 17, 16, 18, 15, and 2. There's 5 pieces of data, so I will divide all of that by 5. And when we add all of those together, the ones place we get 28, and then 2, 3, 4, 5, 6, we get a total of 68. And then we will take that 68 and divide it by 5. 5 goes into 6 the one time, and 5 goes into 18 3 times, with 3 out of 5 left over. So I got 60. I need a different color. 68 over 5, which is 13 3/5. I wasn't sure what to write there at first. Okay, that's what they wanted. So we end up with this measure of center that's supposed to represent all of this data as 13 3/5. And our question is that pretty accurate? Is that kind of the center of the data? Let's order at least to greatest just so you can see. You may be looking at it going, wait, no, it isn't. But let's order it from least to greatest and see. 2 is the smallest. Oopsie. 2 is the smallest. 15 is the next smallest. 16, 17, and 18. I'm also going to put this down on a dot plot so our brains can see it visually too. Okay, there it is on a dot plot. And I think this will answer your question if you weren't sure if this was a good measure of center for 13 and 3/5. This should answer it. Our data is 2, 15, 16, 17, and 18. Of that data, if I do the mean, the average, it gave me the average being right here at 13. And so I'm asking myself, of this data, is that the middle? I mean, does that represent the middle of the data? And it doesn't, right? Because most of the data, the majority of the data is way up here. So it doesn't represent it. It's the middle of the range right there. That's what an average is. But the thing is this outlier, this 2 way down here, it just drags or skews that mean to be lower than the main set of data. And so sometimes when that happens, when you have an outlier on one side, it really will pull the average down. So in that circumstance, then maybe average, the mean, isn't the best way to measure center. And so if you see that on a data set, when we first looked at this, now that we recognize that, if we saw all these data real close together and then this little guy, like, oh, I don't think mean or average is the best way to measure the center on this particular data set. I'll use maybe median instead. Let's see how median comes out and see if it's more accurate. So the median, now that we've ordered it from least to greatest, the median, remember, is the middle number, 16. Well, does 16 more represent the data in the set? That's right here. That a little is quite a bit more accurate than this means measure of center. This is at least in the grouping of the majority of the data. So since the mean is less than 4 of the 5 values, it's 13, and the majority of the values are more than 13, it's not a good description of the center of the data. We found that the median is closer to most of the values. So it is the best way to describe her results in this circumstance. So we would use median as our measure of center instead of mean. Mode, remember, is the most repeated, and since we did not have anything repeated here, then that wouldn't be a good choice. If we'd had 18 repeated twice, then we might have been like, oh yeah, 18's fine too. It's kind of all grouped in together with that. So, but if I had 2 repeated, I might say, maybe that's not the best way. So in time, you'll get used to which is the better way to represent the measure of the center. So Thomas should use the median to describe her results. Let's look at this last part. Explain why the 2 models may be a better description than the mean or median of the data set 2, 2, 2, 2, and 7, 7, 7, 7. I'm sorry. Explain why the 2 modes may be a better description than the mean or median. So in this one, if we had put it on a line graph, you probably in your brain can already see this. 0, 1, 2, 3, 4, 5, 6, 7. We're going to have a 2, 2, 2, 2, and a 7, 7, 7, 7. And so the mean and median is going to put us somewhere in here, but that doesn't fully represent this data set. Since these modes are equal, the most repeated number are equal, then it's better just to say, you know what, the modes are 2 and 7. And it gives us the idea that, okay, there's more numbers here and more numbers here. This data set is like split in 2 separate sections. So that's why that's an example where mode might be a better choice. All right, and now let's look at the variability, the range compared to interquartile range. Which one is a better one to use for this given scenario? Maybe sometimes range gives us a better depiction of what's happening, and maybe sometimes interquartile range gives us a better depiction. So let's see which one this one is. Mr. Tobin is buying a book online. He compares prices of the book at several different sites. The table shows his results. Make a box plot of the data and then use the plot to find the range and interquartile range. Which measure better describes the data, and explain your reasoning? So at site 1, it was $15. At site 2, it was $35. What a difference in price. Site 3, it was $17. Site 4, it was $18. Site 5, it was $5. Site 6, it was $16. And Site 7, it was $17. So in order to make a box plot, remember we need, because box plots are all about the median, we need to write the data in order from least to greatest. So we're going to go through. The smallest number is 5. Cross it off. Then the next smallest looks like 15. So 5's kind of an outlier. We noticed that kind of when we were reading through it anyway. Remember, you heard me say $5. 16, 17, 18. Oh no, I missed a number somewhere. I found it. There were two 17s. And then 18. And then 35, the super expensive book. I don't know what they put in that book that's extra. Maybe they surrounded it in gold or something. I don't know. Anyways, the median is found by going to the middle number. So I'm going to lightly cross off big and small, big and small, big and small, and my middle number is 17. So the median of the whole data set is 17. Make that a better color. The lower quartile are these three numbers. What's the median or the middle number of that? It is 15. And the upper quartile is the median of the upper half of the numbers. So what's the middle number of that? 18. Okay, let's draw our box plot so we can see it. We start the box plot with our median, that is 17. Draw that vertical line there. Our lower quartile is 15, right there. Our upper quartile is 18. That's going to be right in here between the 17 and 19. I'm going to have to squash it in right there. Connect them. And then the box plot, of course, has the whiskers. The lower whisker is the dot at the lowest piece of data in the set, and the upper dot is the highest value in the set. So we have the range and the interquartile range. Nice and tiny box there. That means all the data is really kind of scrunched in that main area. So already you can probably look at it and say, the better one to use between range or interquartile range to get an accurate idea of the majority of these numbers is that interquartile range, because all the other numbers tend to be really scrunched right in there. These are outliers in either direction. So they don't really represent the whole data set. One's way cheap and one's way expensive. Maybe this is fancier for whatever reason, or it's signed by the author. I don't know. And maybe this one's all torn up and used. I don't know. I don't know the reason for the difference in the prices. All right. They tell us calculate the range. So remember, the range is to take the highest number in the data set, 35, and subtract from it the lowest number in the data set, 5. And 35 minus 5 is 30. The interquartile range is to take the highest or the high value, the upper quartile, which is 18, and subtract from it the lower quartile right here, which is 15. And that gives us 3. Now, 5 of the 7 prices, 5 out of the 7 prices, 1, 2, 3, 4, 5, are all within that interquartile range within the box. So since so many of those numbers, so many of the data set lie within that interquartile range scrunched in there, the interquartile range is the better description of all that data because they're all bunched together in there. And the range makes it look like it's more spread out than they really are. Makes it appear that the data values vary more than they actually do. They don't vary that much. Most of the data is here. It's just there's that one that has the author's signature or whatever it is that makes it so expensive, and one that's super cheap, probably because it's all torn up. Somebody dropped it in a water puddle. I don't know. So more of the data is right in here. That gives us a more accurate description of the data. How can we tell from the box plot how varied the data are? Well, we can tell because we know it's spread we look at this spread and we know that all the data is spread out quite a bit. But when you look at a box plot and you see the box, if the box is real long too, if we have something like this, then we know all of that data, the majority of the data is right in here. We know that the whole, all of the data is spread out quite a bit. But if we have, a little box, then we know all that data is scrunched in there and not very spread out. And spread out would mean varied, that there's a variety of numbers. And so in this case, there's not a big variety of numbers, 15, 16, 17, 17, and 18. They're all scrunched together. So you can tell if from the box plot how varied the data is if the box is really spread out, there's a variety of data. If the box is all scrunched together, there's not much of a variety of data. It's all pretty close to the same numbers. So I'll let you word that how you want to, but that's kind of my explanation on that. So you're just going to be really playing with mean, median, mode, and range and interquartile range on the rest of this lesson for the practice, trying to see which gives the better value, the better representation of the data you've been given. So that's all this lesson is about. A lot of practice on the stuff that we've learned, and that's a good thing. And I'm really digging deeper into understanding what those numbers mean. So I think you'll do great. Good luck.